Hello. Okay. Okay. My screen is visible, I think. Okay. So we were solving dynamic programming problems and also picking up one problem from advanced graphs. Okay. So let's start with the problem longest palindromic substring. Okay. 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 So we need to find a substring, means a continuous string uh, in this string S. So here the longest consecutive string palindrome is this BAB, and also ABA is also answer. So ABA. So both having length 3. So we can return the any of the longest palindromic substring. And here the longest palindromic substring is this BB. Okay. So the palindrome is a string which is same when read from forward or backward. So reading from forward and backward is same. That is a palindrome. So we need to find a longest palindromic substring in this particular S. Okay. So the brute force solution is what we can do. We can find every substring of S. First, we can uh, take out every substring of S, and we can check each individual substring if it is a palindrome or not. Checking each substring if it is a palindrome or not. Okay, so this is our brute force solution. So how this will work? First, we will take the substrings of length 1. Okay, means every substring with length 1 is a palindrome. So we can start with the uh, with the substring of length 2. So first we will pick this substring, then we will pick this substring, then this substring, then this substring. These are the substring of window size 2. Then we can take substring of size 3, this substring, this substring, this, then substring of size 4. Okay, and then we can check if it is a palindrome or not. So how we can do this? Suppose n is length of our this particular string, and we can start from here, and then we can have another variable j will be starting from I and will be smaller than this. So what now we will do, we will find the substring between this position I and j. So uh, suppose we let's print the substring first. So what we can do, we can print the substring like s dot substring hmm, between I and j plus 1. So why we are taking j plus 1? So this function does not considers the last index we have passed. Suppose if we pass here value 2, so it will take substring till index 1. So that's why we are adding plus 1 here. So at the end, suppose we return an empty substring. So let's see what substrings we get. Okay, we need to separately print our substring. Okay, so these are our substrings: B, then BA, then BAB, then BABA, then BAD. Okay, then this substring, then this substring, then this, and one by one we can check this substring if it is a palindrome or not. And if a substring is palindrome, then we can check if its length is greater than the existing answer, so we can update our answer. So this will take if done optimally, this brute force approach can take a big of n cube time. Wait a second. And we need to solve it in I think n square approach, which will give us TLE. 10 raised to the power 9 will give us TLE. Means either we can solve it in uh, n square log n or n square approach according to the given constraints. Can we solve it using dynamic programming? We will not waste time greater than 20 or 30 minutes on this particular question. So can we solve it in using dynamic programming? How we can solve it using dynamic programming. So we have this string and reverse of the string will be this string. Longest common substring. Instead of longest common sequence, can we find longest common substring for this? Suppose we are at this index and this index, and these doesn't match, we will move to the next index on both. Okay, if they match, then we have a one matched index. But in okay, so this matches to this, then we can move to the next index. Okay, then next ABA matches. But the answer is suggesting us that BAB also can match. So we can skip from this, take from this. Okay, if we take from this, then we have to take consecutive. If we skip, we have to make our progress zero. Means that the no character is matched till now. Okay. We need to at least we should I think solve it in n square log n. This will give TLE. So for palindromic or not. Okay. We can solve it without DP also. Means we just have to find this substring which is palindromic. So suppose this particular string is a palindrome in itself, then we expand to left and then expand to right. Then these points also match. Then we can expand it to here and here also. So this point doesn't match, so we have this string. And also we can expand from here also. We can expand from every point. Uh, okay, that will give us the odd length of the palindrome, and for the even length we can go like this. I am. I know an approach which I remember because I remember when I have previously done it. So that approach is like means that approach is without using dynamic programming. So let's say we have this string, and we need to choose a substring means which is palindrome. So suppose we have a palindrome. Uh, let's say Nitin is a palindrome. So what we can do, how we can decide whether it is a palindrome? Uh, Two ways in which we can decide it is a palindrome. First one is we can start from their endpoints. Means we can compare this n with this n. Okay, and this I with this I, and t with the t. And other option we have is we can start from the middle. We will compare t with t, then we expand I to I. Yeah, that's the approach I remember. So means we need to expand in the case of odd palindrome, means palindrome with the odd length, we need to expand from means the middle position only. And if our palindrome has even length, then we if we want palindrome so even length, then we can expand from 2 points. Okay, we can implement this approach also. This will be of n square complexity. Means how this will work, we can uh, find the palindrome with odd length. Means for odd length we need to expand from this I. Means our the left and right pointer will be I itself, and we need to expand s. And in the case of this is for odd length strings, and in the case of even length strings we can have two pointers. Means one is I and other is j, which is I plus 1. Suppose we have a answer string s. Sorry, and we can return that answer at the end. This is our I pointer. This is, let's say, our j pointer, and this is our string s, and this is our answer string. So what we can do, we need to expand. So while our j is greater than 0, uh, I is greater than 0, greater than equal to 0, and our j is smaller than s dot length, we can expand into both directions. Okay, towards the left and right by checking its so initially we have this particular string, then we can have these and these. So what we can do, we can check and our s dot character at I equals to s dot character at j. So if this is equal, then we can decrease I and increment j. Okay, so means we have decremented I and incremented j. So this means now our after this loop breaks, means our ith we should not correct, we should take a string from I plus 1 position to uh, j minus 1 position. So means what we can check, if our j minus I is greater than length of the our current answer, we can update our answer as dot substring I plus 1, and in Java we take 1 to 1 means one index greater, means we avoid taking last index which we are passing in this particular argument. So we will take j here. J is not valid, means this will take a substring before j. What if we store the end and in the loop will we iterate? While we iterate. Yes, it may have gone, it must have gone out of bound, means after iterating this loop, it is out of bound, means either it's I greater than 0 or j smaller than 0, or either these two characters don't match. So this means both are out of bound, means we have a greater value, a smaller value for I. Okay, so we need to take a next I. So next I will be I plus 1, which is I, and j will be gone to the j plus 1th position. So we need to take till j. Okay, let's say if we have this string, so here I and j are 0 1 2 2 initially, then we decrement both. We compare these conditions pass and we compare. So character b is equal, so we decrement I and increment j. So I and j now become this, so I becomes 1 and j becomes 0 1 2 3. Okay, so now we check if both are within constraints and the character is equal. So a at one position we have a, and also at three position we have a. So what we will do, we will decrement I and increment j. So now we see these conditions pass, that these are within constraint, and this condition fails. So we break our loop. So now what we need to choose, we need means this string, means string starting from I plus 1. Okay, string starting from I plus 1 is a an ending at uh, j minus 1. So that is a valid string. And what will be the length of this string? Uh, the length will be j minus I, j minus I minus 1. Okay. Let's see if this I think string will not pass by reference, so let's see if this works. Otherwise we can put string in global, or we can, okay, so string is, I think, not pass by reference type. So what we can do, we can put string in global, where try putting string as the global variable, or we can, what we can do, mm-hmm. Okay, what if we put string as a global? Okay, means can we do it using, means dynamic programming? Can we, means like what we do in LCS, means longest common subsequence, means longest palindromic subsequence. Means we also have a question, longest palindromic subsequence. Here we have substring. So in that, what we do, we find the longest common sequence between the uh, given string and its reverse. So DABAB. So can't we do something like that here? Means if we, means let's say we have this original string and a reverse string, means the palindrome will still remain same, because reading from forward and backward remains same. Yes, we need to make some changes to that algorithm. That's, we need to figure out. Yes, we want a substring. Means what we can do, whenever we are skipping a particular character, what we can do, we can make our current length to 0 in that algorithm. It will be something like, let's do it faster. Okay, so we need to reverse this string. So int 10 will be length. I think there's no function to reverse a string in Java. Uh, String reverse Java. Okay. Okay, one thing what we can do to reverse a string is string, let call reverse string as R. We can do new string builder with this substring and dot reverse dot to string. Okay, DABAB, okay, it's working. So what we can do now is we have a string and its reverse string, and we need to find the longest substring. So initially, let's call this function find, and what we can do, we can pass this string, this R string, reverse string, the length, and currently, let's say we are at 0th index. Okay, so let's call this function public void. Okay, okay, so extract that string, we need to find that dp. Suppose we have a length and we have a current index at which we are, so we can extract that string, I think, that substring. Let's see, I also don't have idea, not have much idea. So let's, so we have this string and its reverse string and the size and the current index. So means this is a, let's, this is a palindrome. So means this substring matches in uh, both these substrings. Okay, okay, then also we need an index in first string and second string. We need two indexes. Let's call I in the index in the S string and j in this. So if any of I greater than equal to, this will be R, if means any of the substring, any of the, this is greater than or equal to n, we can for now return, means one of the index is not valid. Okay, Now we need to compare this particular value and this particular value. So if s dot character at I equals to r dot character at j, that means we have found a match. Okay, if we have found a match, okay, so here the problem comes, means how we can decide then how many length till now we have matched. Okay, how we can solve it using dp. We have this substring BABD. BABAD. Need to find this substring which is palindrome or this substring. To make some changes to that algorithm because it configure T1 substring. But to extract these substring we need to transverse that DP to get the answer. Let's see if anyone gives us good hint. But we can't decide that which is our current substring which is matched. Nice. Okay, so you are saying if the character is matched, we can take I minus minus and j minus minus. Means I plus plus j plus plus, you are saying. Because I am starting from 0, so I need to increment I. Otherwise, you are saying what we can do, we can find the maximum of. But what the point of finding the maximum if we can't find the string, means substring, which substring we need to find? Can't we do something like we are in this substring itself, we put our I here, j here, and see if this matches. If this don't match, we can try either incrementing our j here or this here. I think it can't be solved using 1D DP at least. At least it should require 2D DP. Okay. So is it a memoization solution or a tabular solution? We will not discuss tabular solution. I only know memoization part. So can you convert that tabular solution into memoized solution, means in a recursive solution? If it's tabular and it's 2D DP, uh, means we can put I here, j here. Okay. Let me see if I have implemented its recursive solution or not. I think all solution will be same, means using this 2DDP approach. Okay, all solutions are same. It's the same solution. So I think I haven't uh, tried this problem using recursion. Okay, this is also same, but this is using Go. Okay, so we can look for its recursive solution. Otherwise, it will. Okay, can't we find the memoized solution here? Okay, top down. Is top down tabular? Okay, it's I think recursive solution. Is it a recursive solution? Okay, okay. So the solution is like we have a array DP array. Okay, we are using 2DDP. Filled it with -1 values. We are maintaining a answer. Okay, answer means the starting index of a string and length of that string. Okay, means we are taking starting index and that index, adding it to find the substring. Okay, we need to find this fill start index and end index and length into this particular answer. Okay, so what we are doing, we are passing a left pointer and right pointer on this same string, means we are not choosing another string. Okay, and index. Okay, if answer is already calculated, if it's uh, not equal to minus 1. Okay, if it's already calculated, then we are setting L to R as 1. Okay, if it's true, then return true, otherwise false. Okay, single letter empty string is a palindrome. Okay, if our left variable is greater than equal to right, every single letter or empty string is a okay. Okay, possible palindrome beginning. If of our both these characters are equal, means at L position and R position, we are incrementing L and decrementing R. Okay, if it's equal. Otherwise, we can have other possibilities also. Means we will go with other possibilities also. Means we can. Okay. So in you can store that index in this answer global answer array. Means wherever you are storing length along with length, you can also store its index. Can you share your code? Yes, you can share link also. And then we can check for other possibilities also. Okay. If found and the length is greater than the current answer, then we can update and we can add found to the memoized part. We are only using this found variable for this call only. Means we are not using the output from these calls, from these other possibilities. Okay, I have understood the solution, but we will implement it someday, some other day, because now as we have remembered it, so we can implement it easily. So what we can do, we can mark this particular problem as this star that we need its solution, need to implement it. Do I need to share link with you? Okay, we have this function. We are passing a string and its reverse, and both starting from last index. If okay, base condition. If these are equal, you are incrementing a found one single to yes, increasing its length. Okay. Otherwise, you are choosing the maximum between both these. Means either decreasing j or either decreasing I. Means decreasing one of them. So whichever gives the max. Okay. I think we cannot modify this solution to give us the answer. Give us the starting index because we are using two different strings. Okay. We can't modify this to give us the starting index. Okay. Means like this part, one thing you can do is you can uh, without returning from here or here means what you are doing, you are returning from here and here. What you can do is you can instead of returning, you can after these calls calculate the outputs returned from these functions. I think then you can modify this. Means you can store this particular thing and this, and like that question, that solution, you can do here some calculation. Okay, so I really don't know how to solve problems using how to approach using a tabular form. I can in in some questions I can convert a solution to that solution, but cannot implement it. Okay, so we can implement it on some other day. Now, as we have understood it. Okay, so we need to implement this alien dictionary. I think it will take us very. It can take our much of time. Okay, there is a foreign language which uses Latin alphabet, but the order among the letters is not this as in English. Okay, you receive a list of non-empty string words from the dictionary. Okay, list of non-empty strings. Okay, where the words are sorted lexicographically based on the rules of this new language. Okay, words are sorted in lexicographically order. Okay, derive the order of letters in this language. Okay, if the order is invalid, return an empty string. If order is invalid, okay, order of the letters in the string. If there are multiple valid orders, order of letters, return any of them. Okay, in multiple orders, return any of them. Okay, so isn't it sounding like topological sorting? A string A is a lexicographically smaller than B if either of the following is true. The first letter where they differ. Okay, so it's the condition of lexicographically strings. Okay, so for a language is that using letter A, B, C, Z, we receive a list of non-empty words sorted lexicographically. Okay, so this string is greater than this string. Uh, Sorry, this string is greater than this string. This string is greater than this string. Means E is greater than H. Okay. So what we need to return, derive order of letters in the language. Okay. Like we have this order in our language. B is greater than A, C is greater than B. We need to derive order. If the order is invalid, return an empty string. Okay. Means something like if our topological sorting has a cycle, means if the ordering is not correct, means we can return the empty string. If there are multiple valid order of letters, return any of them. Okay. Okay. I think memoization will work for most of the questions. So means if an interviewer asks me to solve a problem, DP problem, so first I will solve it into memoization, then I can convert it into tabular. And if he asks me to uh, do directly it in tabular, then I can simply leave. 5 मिनट देना ब्रो, पानी पी के आता हूँ. ये यार ये करवाना क्वेश्चन ही, ये टाइम लग जाएगा अदरवाइज इसमें. मेरे को तो ये वही लग रहा है टोपोलॉजिकल शॉर्टिंग का ही. until we mess it up. Okay, so this particular example from HRN and HRF, we know n is smaller than f. Okay, because n is appearing, means these are equal, so the order is decided based on this. So n is smaller, that's why it is in front. Okay, from HRF and ER, we know H is smaller than E. Okay, because H is appearing before E. Okay, uh, from ERN, ENN, we can decide R is smaller than N. Okay, from ENN and R, we can decide E. Okay, one possible solution is HERNF. Okay, so what we can conclude from here is we have this particular. Why keyboard is not working here? My keyboard is not working here. Why it's locked? Okay, now it's working. So this simply means कि uh, if these characters are equal, so go we need to go to next compare, means we need to compare next characters. These are also equal, then we will compare these ones. Okay, but one thing we can say is H is smaller than E and E is smaller than R. So this is true because that's why we have this ordering, means based on the first character. Okay. So now we need to decide. Now after this ordering, we will have two groups, three groups. One for where the first character is equal, means for these two H. Another is these after removing the E, and this is after removing the H. Then we have this after removing the R. Okay, so means now the comparison which we will be doing is in between these and these, means from this set our set is reduced to this. Okay, so now doing comparison in between these and this, so these are both equal, so we can skip the R also. So we can say from here is n smaller than F. From here we can say R is smaller than E. Then we will have this empty part, and from here we cannot conclude anything because this is the single string we have. Okay, and from this ordering, okay, how we can convert it to topological sorting? Topological sorting means the node which doesn't have any dependency will come the first. Okay, so let's say we define the nodes like this. Okay, but why R is smaller than E? Okay, we don't have R. It will be R is smaller than N. Okay, means we have edges like this will be a edge, this will be a edge, and this will be a edge. And we can find then topological ordering. So topological ordering will be like H to E, E to R, R to N, N to F. H to R, H to E to R, N to F. Okay. But the challenge is to implement it. How we can implement it? Or will it even gonna work? Means we can have characters which have no ordering. Means, for example, let's say if we have only this string EFG, means here we can't decide the ordering. Means we need to put all these, we need to consider all these characters. Okay, so means we can have a array to store characters which we have. Okay, we can iterate over our words array, over words, and we need to decide ordering. Means we need to keep aside the characters having a first, means we need to group the words having the uh, equal characters in front. Means till the point which we can't decide ordering. Means for this we can decide the ordering, and after that we can check for the first mismatched character. Okay, but it can go deeper. Means like we have A, H, A, F, F, G, H, H, B, H, B, X, Y, Z, and H, H, B, X, A, Y. Okay, and H, B, X, A, Y, Z. So initially we will put H as the smaller, then we will have after removing H we will have these points. So we can say that A is let's say A is smaller than B. Okay, then we cannot decide ordering for this part, then we need to go for these equal values. Okay, means we can put FGH for now in a set, means which don't have any ordering. Now for Bth part we can't say anything, so we will remove the B. For this part now we also cannot say anything, we will remove X. Now we can conclude from here that Y will come, will come before A. We can remove this Y. We cannot say anything for the Z as of now. Now we have these two values having equal, we remove A and A, Y and Y, Y and Y, so which is smaller. Okay, so we cannot say anything of Z. Okay, so here we have a conflict, I think. Okay, F, G, H, Z. Okay, means order will be something like this. Okay, what ordering we need to return? Okay, we can't say that we have any ordering. To looking at this, I think we have Z at the end, Y, then X. Okay, we have H here. That is why we are getting this ordering. The smallest is G. Okay, we smallest is Z here. Why it's not A? Why it's Z? I think it should be A at least. Means A after removing this whole H from the beginning, A is coming here. So why A is not the first? Means the smallest character. Okay, let's look at some hint. Can you think of this as a character from A to Z or nodes? What could edges represent here? How can you create edge from given words? Perhaps you should try comparing two adjacent words. The relative ordering of characters can be treated as edges. For example, consider the word ordered as which indicates that A is predecessor and these dependencies should be valid across all the words. And this way we can build the adjacency list by comparing two adjacent words. You can think of an algorithm. Yes, means I have thought of a correct approach, but I'm not able to find how I can find these edges at least. Means how can I find these edges? Means it's asking me to compare the adjacent words. Okay, I think I have understood how we can do this. Yes, yes, strings. I think this will work. Means we don't need to iterate the whole array at once. We can just compare two adjacent. Means they have some difference. That's why one's ordering is greater, others is smaller. So we can just compare the adjacent ones. Like so we have these words. So word one will be words of zero and word. Wait a second. Word two will be words of one. Okay, so we need to compare these words. So let's say we are at zeroth index in both the strings, and we will iterate while our this doesn't get out of bound these pointers. So so we have started iterating the strings. Okay. Mhm. Yes, by finding the first mismatch character, we can tell that this particular character is the cause of this ordering. Means because of this particular character, this ordering is like this. So we will have a dependency, means from x to y. So for dependency, we can create the map. So like map will be a map of integer, list of integer, graph is equals to new hash map. Okay, so we have this map, and if uh, w1 dot character at ith position is not equal to w dot character at jth position, then we have a means mismatch, and we after this we can conclude and break, and if it isn't a conclusive one, then we can move forward, means if these are equal. Otherwise what we can make is we can create a dependency, means compute if absent from I to j, we need to put. Okay, we can directly put it. Okay, and new array list, if it's not present, and in that array list we will add the w2. I think we also need to find, means all the characters we have in our word, either they are part of topological sorting or not. Means what we are doing in these problems of that characters, we don't have such example here. Means the characters which don't have dependency, like I think we are putting that characters at the start, the characters which don't have any dependency. Okay. Okay, so after we have made our graph, we can have a stack of integer which we will define. We can find topological sorting in this graph. and we can password stack too. Okay, so I have few doubts here. First one is from which particular edge we will start. Okay, and other is we need to also find the unused characters means. Okay, here with this word starting from I j, length smaller, character not equal, word 1, putting word 2, having an edge, then finding the topological sorting. Okay, we can use a Khan's algorithm to find the topological sorting because it can also detect the cycles here. Should we use Khan's algorithm or this DFS approach for topological sorting? Let's use Khan's algorithm. Okay. Where's the Java code? We have this in degree. Yes. Okay, we are already using I here. Okay, so let's say we use K here. Word of K minus 1 and word of K we will use. Okay, then we will use I and J. I don't like its interface. Okay, okay. We are directly putting the value of that particular character. Okay, okay, what we are doing here is we are finding the in degree. Okay, from that graph we are iterating over the values and adding values with 0 in degree into the queue. Okay, one thing we can do is instead of doing this, we can directly put a 0 here. So we don't need to manage this. All this thing means we can start from 0 and go till 26. Okay, having issue in for loop. Which for loop? Where we are running the I. Okay, okay, okay. Then we have topological sorting. The indexes that at zeroth index which node will come. Okay, okay. Cannot find symbol. Which symbol? Okay, we have some issue. We need a E here. Okay, okay. We need to null pointer exception. Okay, where we are accessing our list here. So we need get. Okay, still null pointer exception. Here we are accessing it. Okay, we are accessing it here. Okay, we are just printing 0. We are putting nothing. Let's see if our graph is correct. So we can iterate our graph. Okay, mm, get key, get value. Okay, 49 pointing to 50, 73 to 49. So will contain. Okay, We need a here, a here. Okay, so a point for this example, let's say. Okay, now we have some value in our topo sort also. Next 4 means okay, means 17 means okay, let's for now. So basically we have ordering for 4 A, B, C, D, but we don't have any D here. Or it's just the map. Let's not print this for once. Okay, so 17 and 13, 4 and 17, 7 and 3, 13 and 5. Okay, we are getting E, then F, then N, then R. I think we can solve it tomorrow also. Okay, Means how we can separate in degree, like we can do something like instead of we can check if it's -1, we can just make the in degree to 1, otherwise we can increment the in degree. Just doing for ones. Okay, we can increment it in degree. So only considering having in degree 0. Okay. Okay, I think now we are getting HERNF. Okay, and this is expected output. We are not getting any. Okay, so this is expected output, not the what we have printed. Where console, where's the sheet from? Okay, okay, solar 0. This means nothing is getting filled in opposite. Okay. Okay, so we can solve it tomorrow also. We will continue it from here only. Now I'm getting blank, so I think I should sleep. Okay, guys, good night.